Welcome to the last part of Competency 9 quiz questions. In this video, we will answer questions relating to trig functions, inverses, and identities. Number 12. The highest function value of the graph of f of x equals 6 cosine x minus 3 pi plus r is minus 2. What is r? Okay, so with this wording, it's the way they worded it. This highest function value is actually the negative 2. Okay, so we have to think about that. And then they're asking for r, which in this situation, we just need the amplitude. Okay, so how do we get that? We know that that is going to be d, but in this case, d equals r. Okay, so that would be d plus a, because this is highest value. You go from that midline D and add, okay? Right, so A equals minus 2, okay? And we know that A is 6, so that gives us this quick little equation that we need to solve, which is D minus 2 minus a 6, which is obviously the negative 8, okay? It's a very basic problem, but it does involve property that might be part of a more rigorous question as far as the practice test or an actual test, okay? All right, now let's look at number 13, okay? What are the values of x in the equation for cotangent x minus tangent x over 3 equals 0? Okay, this one is a little more involved, so let's write that out and start solving. Well, the first thing that we need to do is realize, okay, if you remember your identities, that cotangent of x actually equals 1 over tangent x, okay? So let's rewrite this and we can start solving that, okay? And the first thing that I'm going to do, yes, I'll write the 4, okay? Actually, I can say 4 over tangent x because we're replacing this with this, okay? All right, so 4 tangent x, and that is actually equal to tangent x over 3, okay? So then what do we need? What do we need to do? Okay, so we need to multiply both sides by tangent x over here times tangent x, okay? So this means this tangent, and this tangent are canceled out. So then we have 4 equals tangent to the second x over 3. So if I multiply both sides by 3, then I have even more I can work with, okay? So that just becomes 3 over 4. Of course, these two are canceled out, okay? And 3 times 4 is 12. So now we have 12 equals tangent to the second power x. So if we put 12 under the square root, now remember, it's positive, negative, then we know what tangent x equals. We know the value, okay? But we're going to need angle measures, so we need to take that positive 12 and the negative 12 under the square root, and then use the inverse tangent. Okay, so let's do, I'm going to do different colors so we know the difference. So this is what we need. Tangent, inverse, square root of 12. Okay, we'll leave it positive, but we also need tangent, inverse, minus square root of 12. Okay, and that's what we'll put in the calculator. All right, so second tangent, and let's do the positive first. Second radical 12, arrow over, close your parentheses, and push enter. Well, that's 72, which should be rounded, which makes sense, to 74 degrees. Okay, and this means we have 74 here, 74 here. Now we don't have 74 in C, so I'm going to have to say I disagree with it. Now we're missing 74 also in D. So let's kind of like think of it as probably not going to happen, okay? So now let's try the negative. So then we have second tangent, second tangent, and we need the negative, then second radical 12, arrow over, parentheses, and of course that gives us the negative 74. So how do we deal with that? Well, that implies that we have 360 minus, you know what, I'm going to go up and grab that. Oh, however, if I grab it, I'll have to get rid of this here because it's a negative. So, no, yeah, I could do it. That would mess stuff up though. Let's just use the 74. I was trying to think that'd be great, but in this situation, if you look at it, that gives us a negative 73.89 blot, da da da. What happens is we're having to subtract and the negative's already there, and that's just not how it works, okay? Kind of defies what we're trying to achieve, okay? So really 286. Well, I see that here. Okay, so that tells me A is not an appropriate answer. And I don't see any of the appropriate answers in D, to be honest with you. Yes, B is most likely the correct option, but we do need to check the 106 and the 274. And how do we verify those and how do we justify them? Okay, the first thing is we have positive and negative values of tangent. Okay, if we want a positive, that means we can go with quadrant 1 for the positive value. Okay, so that's quadrant 1, but we can also go with quadrant 3, 1 and 3. So we can take the 74 and add 180. Well, that's the 254. So now we have 254. There's a check mark there. And the same would apply for the negative 74. Well, if we have that negative value, this can also happen. The negative is in quadrant 2 as well as 4. Okay, so that's going to happen in both. So this tells me that we can take that 286, but we need to subtract 180, okay, to get us back to that quadrant, and that's 106. So all 4 of those degree measures are valid. Okay, so it's obviously option B. We have convinced ourselves. Okay, now let's go with number 14. All right, now it says, what are the values of x in the equation secant squared x minus 7 secant x minus 8. Okay, since we have only secant and we're working with secant, we can see that we can factor them out. It is in a quadratic format, okay? So let's factor this out. Well, the first thing that I see is we have a negative 7 here in the middle. That tells me that I can use minus 7 and plus 1 here. So, yeah, so just it's a pretty basic factoring situation. So, secant x plus the 1 and secant x minus, okay, here, now, let's see. Delayed reaction with my computer, always nice. Okay, there we go. All right, I can write this a little clearer so we see what's going on. Okay, secant x, and then it has to be plus 1. Okay. No, that's 8. Oh my gosh, I was looking at the 7 and wrote 7. That would be 8. It only makes sense with 8. There we go. All right, so now what do we have? We have that basic situation because 1 times minus 8 is the negative 8. And if we take negative 8 plus the 1, that gives us a negative 7. Now it's correctly factored. Okay. Right. I thought one thing and wrote down another. Not a good thing. Okay. That just proves you should always check twice at your rationale and maybe pop some things in the calculator just to double check mistakes like I made. Okay. So we have secant x equals the minus 1. Okay. So what we have here is that we can use inverse cosine using the minus 1. Okay, now think about it. It doesn't matter. Okay, we don't need to use a reciprocal because the reciprocal of negative 1 over 1 and 1 over negative, they're the same thing. So it's okay just to use it as is, all right? Okay, then if we look at the other one, that is secant x equals 8. Okay. And we know that we can use cosine. However, we will have to use a reciprocal of 8. And that is cosine inverse 1. But that will be 1 over 8. Okay. All right. Okay, now let's pop these in the calculator and see what happens. Okay, let's do the negative 1 first. Okay, so inverse cosine minus 1. All right, okay, 180. Let's think about this. When cosine equals 1, it's related to pi on our unit circle. Okay, so that 180 makes sense. But it doesn't make sense on the other spectrum when it's 1. Think about it. That's not the same thing. That would be what? If we put that in the calculator, that would be 0. That's 0, not 180. So it just doesn't work out. Okay, 180 does, however. Okay, all right. Now let's keep going and you'll see. Think about it. If you've got your you have 180, okay, and that's related to pi and negative 1 with the cosine, and we have 0 over here. Not quite the same thing, okay? So there isn't, we can't, let me just say, we can't just subtract 180 and be in a related quadrant. I think we have to accept the fact that we have 180 and then we move on to our other value, okay? All right, so that's second cosine inverse. Now that's 1 divided by 8 and push enter. Makes sense. Round that to 83 degrees. Okay, now that makes sense. Okay, so cosine is positive in quadrant 1, and it is also positive in quadrant 4. So what do? We take 360 and we subtract that. I'm going to go up and grab it and push enter again. And 277, and it does round down. So that would also be 277. Okay. Because of the uniqueness of this value for the inverse cosine of negative 1, that's the only value in that situation that's related to it. So we only have 3 values, and that gives us option C. Okay, let's go on to number 15. Number 15. What are the values of x in the equation 3 cosine 2x plus 22 sine squared x minus 4 equals 0? Okay, for this problem, the first thing I see is that we need to use the equivalent value for the cosine 2x, which would be 1 minus sine squared x, okay? So what do we have here? We have 3, 1 minus sine squared x plus the 22 sine squared x minus 4 equals that 0, okay? Now we have some distribution to do, which gives us 3. Oh, I forgot the 2. Oh, that has to be 2 right here. 1 minus 2 sine squared x. There we go. So that would be minus 6 sine. Okay. All right. And if you want to verify, that I really should have written the 2 there, that is actually the identity, go look it up in your notes. Okay. Unfortunately, you won't have this on your formula sheet during even a practice test or the actual test. So this is just something that you need to know. And sometimes I don't see little pieces I miss until I write it down because I am used to seeing it in notes and other places. And when I saw it and I tried to distribute, I was like, no, this is wrong. Okay, so we have 22 sine squared x, okay, minus 4 equals 2. So now what do I need to do? Well, we need to do some combining of like terms here, okay? So we need to uh, put these together, okay? And then we need to put these together, all right? So we will have, well, if you take 22 minus 6, always use your calculator during a test. I've stated that many times. Don't try to do everything in your head. That's when mistakes are made. Okay. And I make enough of my own. So I put everything in the calculator. Now, what do we have? We put those together, sine squared. Now, 3 minus 4 is minus 1. Okay, I can just erase this over here. Didn't need that. Okay, so that's going to equal 0. So now what do I do? Well, I can say 16 sine squared x equals 1. Divide both sides by the 16. The 16 over 16 cancels. And to get sine, we will just put, we have sine x. Remember your positive, negative, and put 1 over 16, okay, under the radical. Now, of course, now we just need to use the sine inverse, okay? And then we will put either, first we'll do the positive, then the negative of this square root over 16, okay? So let's do that and see what happens, all right? So we need second sine, positive. So let's do second radical, and then 1 divided by 16, arrow over, close it, and enter. And we see a positive 14 that will round to a 15. Well, I see that here in D, and I see that in A. Okay, so we have some possibilities. Now let's repeat ourselves, but with the negative value. Okay, second sine, okay, negative, second radical, 1 divided by 16, oops, don't want to do that. Divide, arrow over. Now close your parentheses and enter. And we get a negative, okay, and negative 15. Here's the thing. Do you see how they rounded that? I think I can kind of see why they did, but you see how what I mean about a rounding error. When it comes to rounding, we actually don't teach it in this manner because it's 477, but sometimes it works better. So that's why we're going with the 15. Okay. All right. So this tells me, let's think about it. Sine is positive in the first and second quadrant, yet it is negative in the third and fourth. Okay. So what we are doing with that is saying, okay, uh, we have the 15, so we have 360. We're going the other direction. We're using quadrant 1, okay? So minus the 15, push enter. Well, that's 345. Well, that's over here in D, but this eliminates some things, okay? I'm thinking that B, A, and D won't work. However, let's keep trying, okay? Because I'm not going to agree with this 4 degrees on either of those, all right? Okay, but let's think about this. If we have all of those quadrants to use, so if we have 15, okay, then we can use all 4 quadrants. So we can say 345 minus 180. That gives me the 165. Okay, then I can also say 15 plus the 180, and that equals 95. So that would be the only option that would include all 4 quadrants correctly. C does, but automatically when they said 4 degrees, I was like, well, that just isn't going to work. Okay. All right. All right, let's go to number 16. Now, number 16 is just simply a matter of knowing how to read the question and figuring out what they're talking about. Okay. All right. Point Q is located at CD on the unit circle. Now see that O, see how it looks? They mean 0. I'm a little upset with the fact that they didn't make it clear that that was the origin, but it is, okay? If the segment 0q represents the terminal side of the angle theta and CD is not equal to 0, C or D, either one of them, which one of the following statements is false? Okay, so this is really what we have. We're going to draw it, and we're going to say that this is O, or the origin. Then I'm going to go out, once again, pretend that I can draw. Okay, then we have, it says, represents the terminal side of the angle. Okay, so we're going to go up, and then this will be theta. Okay, actually, let's draw that a little bit better. Okay, let's see here. Yep, definitely could draw that better. Let's draw the triangle. Much better idea. Okay, go up like this, up like this. This would be the right angle. This would be Q. So then this is the given angle, right? Given line. That's the segment that they gave. So if we're on the unit circle, okay, this would be R, and R would be equal to 1. So that means that OQ segment is equal to R. And this would be our theta. Okay, now that being said, that means that the angle theta and CD. Now look at CD. C is in the X position and D is in the Y position. So this would be C and this would be D. Okay? All right, now let's look at it differently. First off, they say tangent theta is equal to DC. Okay, remember, we're looking for false. Yeah, that is a tangent. Now that I set up our unit circle triangle. Okay, so we don't want that one because it's true. Let's look at B. B says secant theta equals C. Well, that's not hard to figure out. Okay, so secant x equals 1 over cosine theta. All right, so 1 over what? How do we get cosine theta? Well, that is adjacent over r. So that is C over 1. And actually, in this case, that would be like saying 1 over 1 times 1 over C. And that, oops, that looks like a 6, not a C. Okay, 1 over the C. Okay, well, when you multiply all that out, you get 1 over C. So this is not this. Okay, so oops, I should have circled that because we're looking for false. So that probably, I would say, if I did it correctly, pretty sure I did, that that's our actual guy. Now let's look at this. C, look, we have to do C and D just to verify because if you notice, you can find mistakes if you have made them. Okay, so sine would be opposite over the radius. Well, that is D over 1, which equals. So that's correct, and it's not the one we want. Okay, now we've already stated the obvious that OQ equals 1. Well, we know it does because it's a unit circle and it has to. So, yes, the false item would be B, secant equals C. It does not. Obviously, we are correct. It equals 1 over C. Okay, this will be the last question in our third part of Competency 9 quiz questions. And once again, thank you for watching and sharing and liking, and happy testing.